Hi, my name is Shehroz Ahmed, and in this video I'm going to discuss a topic of linear algebra, and the topic is matrix transformation. So let's suppose we have been given a matrix and we have to transform it. So that how we can do that? So let's suppose let's first define the matrix transformation. So let's suppose given an M cross N matrix A, we can define the function of transformation as we can define the function transformation such that the matrix R with order n to M by the rule T of x equals to A of x. Alright, so in this one we have to understand some terms, like maybe the students will get confused, like what I have written over here, like t such that r to the power of n with an arrow sign to the power of m. So basically r of n, it represents the domain of the matrix. So r to the power of n expresses the domain, r to the power of m expresses the codomain, and t of x, it represents the image of x under the transformation t. So what will happen to the matrix after its transformation? So that is called the image. So it represents the image of x under transformation t. So the name of the transformation is t, and the result is t of x. All right, now there is another term that we have to understand, is the range of the transformation. So I'll write it here, the range of the transformation. So the range of transformation is basically, it is the set of all the images that we get after the transformation of a particular matrix X. So I can write it over here. It is the set of all the transformations, or it is a set of all images T of X that we get as the result of the transformation. So that is called the range of the transformation. So these are some of the terms that we have to understand. And over here, A of x represents the image of x under transformation T. All right, now let's do some question, and let's apply a transformation to a matrix. So let me just erase. So let's suppose we have a matrix A. Matrix A is represented by 2, 0, -3, -1, 4, and 5. We apply a transformation onto this matrix, and the transformation that we have to apply is represented by another matrix that is 1, 2, 3. So this is the transformation that we have to apply onto the matrix A. So we will write it like this. We'll write down the matrix A first, then we'll apply this transformation matrix, we'll multiply them, and we'll get the image of the transformation. So this is 2, 0, -3, -1, 4, and 5. And the image that we have, the transformation matrix is 1, 2, 3. So now when we'll multiply them, we'll get the answer. So that would be 2 times 1 plus 0 times 2. We'll multiply the rows with the column, and then the second row with the column. So 2 times 1 plus 0 times 2 plus -3 times 3. So that will be equal to -9. Similarly, we'll multiply this row with this column. So -1 times 1 plus 4 times 2 plus 5 times 3. So now when we'll solve it, we will get 2 minus 9, that is -7, then -1 plus 8 that would be 7 plus 15, that will be equal to 22. So the image that we get as a result of the transformation will be this matrix, -7 and 22. All right, now let's apply another transformation on the same matrix A. So the transformation is T with the transformation matrix 5, 6, -2. So it will become 2, 0, -3, -1, 4, 5. And now the transformation matrix, that is 5, 6, -2. Now we will find out the image by multiplying these two matrices. So 2 times 5, I'll multiply the rows with the column, So 2 times 5 plus 0 times 6 plus -3 times -2, that would be equal to 6. Now I'll multiply this row with this column. So -1 times 5 plus 4 times 6 plus 5 times -2, that will be equal to -10. So I'll just write 5 times -2 over here. And then the image that I will get will be equal to 5 times 2 is 10, 10 plus 6 is 16. And from here, -1 times 5, that is -5, plus 24, that would be equal to 19. And 5 times 2 is -10, so my answer will be 9. So the image that we will get under the transformation 5, 6, -2 will be 16 and 9. So this is how you can apply the transformation on any matrix. All right, so after this one, we have to do a full-fledged example where we will find the image, we will find out the transformation matrix, and we will find out the range, or we will check whether a given transformation is in the range, or whether a given image is in the range of the transformation or not. So let's start off with the full-fledged example. So there's a matrix A, which is 1, 3, -1, and -3, 5, 7. In the first part, we are asked to find out the image of the transformation to -1. So the question is, find image of 2, -1 under transformation T. So basically this is the transformation matrix. So it's simply T of 2, -1, and we have to find out the image under this transformation. So we'll write down the matrix first. So 1, 3, -1, -3, 5, 7, and then this image, that is 2, -1. So now we'll multiply the row with the column. So it's like 1 times 2 plus -3 times -1, that is 3. Then 3 times 2 plus 5 times -1, so that will be equal to -5. Then -1 times 2 plus 7 times -1, that is -7. All right, so we will get 2 plus 3, that is 5, and 6 minus 5, that will be equal to -1. 6 minus 5, 1, and then we will have -2 minus 7, that is -9. So this will be the image of the matrix under the transformation to -1. Now let's see the part B. All right, so in part B, we have been given the image. So T of x is given as 3, 2, -5, and we are asked to find out x, which is basically the transformation matrix. So we can write it like this. It will be like A x will be equal to the image. So this is the image vector, image matrix, and we have to work out the transformation matrix, and matrix A is given over here. So it will be like this: 1, 3, -1, -3, 5, 7. Then the transformation matrix, that I can write it as x1 and x2, and the image that I will get is 3, 2, -5. Alright, so from here I'll form the simultaneous equations, and then I'll work out the value of x1 and x2. So I'll multiply the rows with the column on the left side of the equation. So it'll become, on the left side I will have 1 times x1, that is x1, minus 3 times x2, that will be equal to minus 3x2. Similarly, 3 times x1, that will become 3x1, and 5 times x2, it will become plus 5x2. Then minus 1 times x1, that will be minus x1, and plus 7 times x2, that will be 7x2. It will become equal to 3, 2, -5. So the equations that I will get will be like x1 minus 3x2 equals to 3, 3x1 plus 5x2 equals to 2, and minus x1 plus 7x2 is equal to minus 5. So when I'll solve them simultaneously, I'll get the values of x1 and x2. So x1 will be equal to 3 over 2, and x2 will be equal to minus 1 over 2. So the transformation matrix x will become equal to 3 over 2 and minus 1 over 2. So this will be the answer. All right, now let's move on to the final part C. All right, so in part C, it asks that is C equals to 3 to 5 in the range of T. So this is the question. So the question is basically like, if we multiply a matrix A with some transformation, can we get this answer? If yes, then it is in the range. If not, then it's not in the range. So we'll do the same working as we have done in the previous part. So it's like 1, 3, minus 1, and minus 3, 5, 7. So if we multiply matrix A with the, let's suppose, a transformation matrix, that is x1, x2, and we will get 3 to 5. So from here I'll make the simultaneous equations, and if the solution of those simultaneous equation is possible, then this image, this matrix 3 to 5 is in the range of T, otherwise it's not in the range of T. So let me just write down quickly the simultaneous equation. So it will be like 1x1 minus 3x2. So I'll write it as x1 minus 3x2 equals to 3. Then from here, rows times columns. So 3 times x1, that is 3x1, plus 5 times x2, that will be plus 5x2. It will be equal to this one, that is equal to 2. Now this is minus 1 and this is 7. Okay, so minus 1 times x1, that will be minus x1, plus 7x2, it will be equal to 5. So we have these three simultaneous equations. Now we will check whether its solution is possible or not. So if we try to solve them simultaneously, then we can see that their solution is not possible. So we will say the solution of these simultaneous equation does not exist, so no solution. Hence I've just skipped this part because you can solve these simultaneous equations in the calculator, so you will not get any solution. You will get solutions like -2 equals to 3, or something like 4 equals to 7. So when you come across such situations, then it means that the solution is not possible. So basically the solution for this will not exist. Let's do it. So let's solve the equation 1 and 3 simultaneously. So when we add equation 1 and 3, let me just erase it. So equation 1 is like x1 minus 3x2 equals to 3, and equation 3 is minus x1 plus 7x2 equals to 5. So when I will add them, it will get cancelled, and from here I will get 4x2 equals to 8. So my x2 will become equal to 2. I will insert this x2 into equation number 1. So x1 minus 3 times 2 will become equal to 3. So x1 will become equal to 3 plus 6, that is equal to 9. So I will get x1 equals to 9. So I will have x1 equals to 9, x2 equals to 2. So it satisfies this equation, it satisfies this equation, but it does not satisfy the equation number 2. It means it has no solution. So we will say it has no solution, hence the image 3 to 5 does not exist in the range of T. Alright, so this is how we will do the questions related to the matrix transformation in the linear algebra. So I hope you understood the concepts and liked the video. So thanks a lot for watching.